Normally, budget printers cut corners in terms of filament range or lack of common features. It was sort of hard to say that about the Centauri Carbon, and I am afraid I am similarly stuck with its successor. Because this printer is, yes, a budget printer, but it's also a printer that can print high temperature materials. It has multicolor, a carbon filter, an easy to use interface. It is enclosed. It has an RFID reader, and it has a very respectable speed. This is not the Centauri Neo or the Centauri SE. It is the Centauri Carbon, and yes, it is emulating other printers, but despite the name, it is not a carbon copy. Hey guys, I'm Coffee, welcome to 3D Jake, where we sell printers and stuff. And this is the Elegoo Centauri Carbon. Stick around, we're going to find out what this chap is all about. Okay, basic specs first. Let's break out the old manual here. Okay, that's a joke, but everything here is very similar to the version 1. The size, the bed, the motion system, the print head, it's all really similar. The only apparent differences visually are of course the top hat and the multicolor unit. Despite this, there are upgrades to the V1, and I think it's better to view the basic specs of this printer not as a standalone thing, but in contrast to the version 1. So let's first talk about what I loved most about the CC1, that being the 320-degree hot end. If you've watched our videos before, you'll know that the Centauri Carbon version 1 was capable of printing high-strength, high-temperature materials like PPS-CF 10. This can do the same, but now the temperature is higher. It's no longer 320 degrees, it's 350 degrees on the hot end. Now 320 degrees was doable with PPS, but just about. I think it came out nicely, but with a very slight surface artifact that are probably due to the lower temperatures. 350 degrees makes printing PPS a lot more comfortable. I had no real issues getting a successful print, besides the fact that PPS-CF 10 is an incredibly brittle filament. Despite this, it was still easier to print than with the CC1 because of the lack of sharp angles where the PTFE meets the extruder. Unlike with the CC1 where I had to remove the PTFE altogether, I could actually put this on the spool holder, feed it into the canvas unit and through the PTFE tube to the extruder, and I had no breakage. And I know people don't like the top hat here. It doesn't look great, it looks pretty awful. But frankly, I think it's good so that there is space for the PTFE tubes. There are not many printers out there that can actually print such a brittle filament on a color swapper, and certainly none in this price range. I also asked Elegoo directly whether the canvas unit uses hardened gears for the feeding. It does. The nozzle system they use here appears to be exactly the same as the CC1 with the exception of the higher heat. Even the flow seems to be the same. We did a volumetric flow test, and with standard PLA, you're hitting around 25 millimeters cubed per second at normal PLA temperatures. After that, you're going to start to see problems. With high flow filament and higher temperatures, yeah, you can get up to 32. These are brass nozzles with hardened steel tips. There is no copper core and no CHT style internal geometry. As the nozzle system is the same, you can use old CC1 nozzles with it. You are working with, well, let's be honest, it is old-fashioned. We have a very classic heater block with heat break and heater and thermistor and removable volcano-style nozzles, rather than the more common and more modern integrated system. Old design, yes, but it works. Unfortunately, quick swap is not a concept Elegoo understand just yet. It is the same process when you are removing the hot end. You have to remove some screws and such, and that takes a few minutes. So material capability upgrade confirmed. The bed is exactly the same. The build plate, exactly the same. And yes, you can fit bamboo plates in there. Slightly smaller, but usable. The bed hits 110 degrees at max 2, and it is like the CC1, AC powered. No changes there. The same goes for the leveling system. However, there is, much like clipper printers, the added feature of adaptive leveling, or as they call it, partial bed leveling. This just probes the points where the model will be in order to save time by not leveling the entire bed. And the build volume is the same, 256 millimeters cubed. The build plate is dual-sided. You have a standard textured PEI on one side, and on the other side you have a finer texture, and this side is suitable specifically for PLA, and you can print with that side at 30 degrees. And I've tried this and yeah, it works fine. However, for pretty much everything else, I have been using the rougher side. I'm just used to that, and there is no problem with adhesion with that side. I actually think it's kind of unnecessary, save for the option of giving you a slightly different texture on the base of your prints. I think I would have preferred a totally smooth side. I still wouldn't have used it, but it would have been better. Touchscreen and interface are mostly the same. The screen is slightly larger, and interface-wise it has the extra features for the multicolor unit. Everything is very easy to understand. It's not packed full of details, but just made for ease of use. It does have a new AI assistant and error detection like a lot of other printers. To be frank, this is sort of superfluous. I haven't had the need to use the assistant. It does export error logs via USB, but you can't seem to do that via the slicer, which is not so neat. The AI assisted camera, haven't had the need to use that much, which I guess is good. The only time it did pause once during the print, and we need to talk about that later. However, the printer does obviously also rely on sensors as well. There is a clog and tangle detection in the canvas unit. There's a run-out detection in the printhead and in the canvas as well. There is also a fan and part cooling fan speed drop detection, so kind of going more in the direction of Prusa. I guess they have a tachometer built into the fan, and we've had no red flags there. One cool thing is the chamber vent, which will open for PLA when the chamber needs to be cool, but it will close for ABS when the chamber needs the heat. But with the placement of the carbon filter, if the vent is closed, then there is no airflow to the carbon filter. Perhaps that's not a big deal for PLA, but I'll leave that to you guys. Continuing on with the interface, the slicer uses Orca, or rather, Elegoo's version of Orca. It's Orca. Everything you know and love about Orca. You don't need to bind this guy. You can do LAN only, which is what we're doing with ours. On the device page, you can load up multiple tabs for different printers, which is cool, although I would have also liked multiple tabs for the prepare and preview windows. I often need to load multiple instances of slicers, so please, someone, more tabs. The interface for the device in the slicer, however, is pretty sparse. There is nothing advanced here. You have basic control options and a view of the print in progress. One funny thing is the camera placement, because when the printer is cutting the filament during a filament change, it actually blocks the camera view for a little bit. And also when you try to make the camera view larger, it just loads up a window with a never-ending progress bar. I also noticed a slight temperature variance. I actually don't know what tolerance filaments can take in regards to temperature, but a 2 to 3 degree difference might not be that great. I haven't noticed anything with the print quality, but it is there. The feet are different. The original CC had basic hard rubber feet. These ones are much softer vibration dampening ones, and I can confirm that these do make a very noticeable difference. When I test printers, I usually have them on a desk next to my main desk, and that desk it's just a normal office desk. It's not particularly stable. When I was testing the CC version 1, I did notice quite a bit of vibration, which actually translated to my desk as well. But when trying out the CC2, that was much more reduced. Noise-wise, it is less than the original CC. I mean, the first release version is what I mean, because the upgraded one had less noise. And thank God they have given us a good LED this time, and you can actually see inside the printer. The canvas unit has an RFID scanner, and Elegoo are rolling out an open source RFID system. In the future, you'll be able to get RFID chips and just stick them on your spools. It doesn't scan automatically though. You have to hold the spool to the canvas unit and it will scan, and then the printer will prompt you asking on which spool holder you want to put that filament. Speaking of the spool holders, they are suitable for most spools, but not all spools, because I tried some Prusa a few days ago, and yeah, that just wouldn't go on. The hole is too small. So any spool with a hole diameter of less than 52 millimeters, that's probably not going to work. But I think they've kind of redeemed themselves with the spool holders, because they're super easy to remove, and the mounts too. You can just slide them off, and the mounts themselves are bolted in. You actually have to assemble this and the canvas and the wiper and poop chute when you get the printer, but the fact that the mounts are disassemblable and attached with a normal bolt means that you can just make your own. And the holders themselves are also actually pretty smart. They are in fact spring-loaded, so when a spool is being printed and it is turning, It just turns, but when there is a color change and the filament is retracted back onto the spool, it springs back to the amount needed to respool that filament. Neat. And this mechanism can also be disassembled because there are stickers accessible just under the sticker. I can see mods happening. Okay, let's talk about the canvas unit. So a few months ago, we put out a 6 months later video on the Centauri Carbon version 1. And I spoke about why I didn't use that printer that much, and one of the main reasons was because it didn't have an AMS type system. And I wouldn't have been using the AMS for multicolor, I would have been using it as a filament selection system. With this, I could choose out of a few filaments that were already loaded in which I wanted, because at home I don't have many colors I use. Like, I mostly just use black and white, and then maybe there's a beige or another color. I hate changing spools, so having the option with an AMS system to choose which spool that I want from the comfort of my kitchen while I make a nice quiche is very awesome. And now we have the CC2 with that system. Almost, because it's not enclosed, it's exposed to the elements. We almost had it, guys. We were so close. It is cool to have a filament selection system, but without a dry box, that's not perfect. Because I think when Elegoo were releasing the CC1 and also the CC2, they had a very wide demographic in mind. So they had a printer that was designed for beginners. This is suitable for beginners, but also to budget conscious, but also to people who wanted to print high temperature materials, high strength engineering style materials. And to have this printer with the multicolor option and of course filament selection, but without a dry box in order to maintain streamlined use of said nylon, it hurts me a little. So that's the basics of this printer. There are good things and there are bad things, but let's talk about results. Elegoo prepped the tiniest sample models, but here we go. Let's start off with the Benchy. It came out decently as well as the others. The bridging on this Eiffel Tower was good. However, it became clearer that with the generic profiles, I had some under extrusion with some PLA, especially with the top layers, and it is more apparent in the HueForge prints I did. Of course, a few little changes to the profile and things were better. By the way, if you ever have top layer flow issues with bamboo, Orca, or Elegoo slicers and such, there is a specific setting for that, which makes it super easy to fix. I had one issue with this Catbus pencil holder. You see the ears? Now this was partially my fault. My poop container overflowed and the chute got blocked, and that blockage knocked off the print head cover, and the printer recognized this and paused the print. Apparently this can happen. This print head cover is magnetically attached, so it's not the strongest. Unfortunately, when the printer pauses, it parks right above the poop chute, making it very difficult to unblock when it is paused. After PLA, I wanted to see how well ABS printed, and definitely had to try our new ABS and ASA CF filaments. This is where I noticed that the first layer wasn't great, and I had to add a Z offset for ABS and ASA. No biggie, and the parts actually came out really lovely. Okay, let's move on. Next up is nylon carbon fiber, and I printed this utility knife. Everything good, although maybe some small area compensation might help with the whole parts. I also decided to print something pretty in nylon CF because I'm a degenerate, I guess. And yes, I now own the toughest, most rigid, useless thing ever, but at least it looks pretty. The only issue here was the overhangs because, well, it's nylon. And of course the PPS-CF 10. It actually looks pretty similar to the quality I had with the CC1, in fact. Maybe that's just how PPS looks. But it was a very successful print. Let's listen to it drop. That never gets old. I honestly don't know how well this printer will be received. Normally I have an inkling, but this one kind of confuses me, mostly because of the lack of dry box. But also, you should know that there is no additional ports to extend the canvas unit, so you can't daisy chain these. It's going to be 4 colors only. And I did ask Elegoo directly about this, and they said they had no development at this time to make a standalone canvas unit. Since late last year, the focus has been primarily on tool changers in the community, so I kind of worry that this printer might be overlooked because of that. Maybe, like the V1, we might see some sort of firmware reversion like the Open Centauri project. However, that's probably only going to appeal to a small subset of the community. I like this printer, I do. It's good, but good does not mean relevant. But if you're on a budget, this is the way to go. This is the most affordable enclosed multicolor printer that we have available right now. The next closest is the Anycubic Cobra S1 combo, and this has massive advantages compared to that. The only disadvantage this one does have is the fact that it doesn't have a dry box or drying option for the multicolor device. If I had to choose between those two printers, I wouldn't even have to think about it. It's this printer. It just has greater filament range. Next after that is the P1S combo, and it's the same story. It has a 300-degree hot end. Next after that is the K2 combo, same story. And after that is the P2S combo, which is where we might have some options, but it is still a 300-degree hot end. The only real contender to this printer is the Cheetah Q2 combo, because that has a hot end that goes up to 370 degrees and active heating, but it's still €200 more expensive than this printer. That's what this printer has going for it. It is affordable and it's decent quality for what you're getting. Elegoo always wanted to create a budget printer and they are successful. And it has some foibles, yeah, it has some advantages and disadvantages, I'll agree. But it is a pretty good printer for that price. Thanks for checking out our video, guys. If you have any questions about the Elegoo Centauri Carbon 2, then let us know down below in the comments. You should also know that we have a Discord server where there is printer talk on a daily basis. We'll be back with another video next week, so until then, later.